Exercise 1F, question 1. Calculate the mean and standard deviation of the following masses. Measure to the nearest gram using a suitable assumed mean. So mass and frequency. So masses are given 241 to 244 and so on. 241 to 244, 245 to 248 and so on. Frequencies are given 4, 7, 14 and so on. Alright, we have to use assumed mean method, which means we have to consider one value to be mean. Now I don't have one value. What I have is a group. So I have to figure out one value which represents the group. So I consider it to be mid value. How do I find mid value? 241 plus 244 divided by 2. So this is 242.5. 245 plus 248 divided by 2. 246.5. 249 plus 252 divided by 2. 250.5. 253 plus 256 divided by 2, which is 254.5. 257 plus 260 divided by 2, which is 258.5. And 261 plus 264 divided by 2, 262.5. Now if I had odd number of value, here I have 6 values. So because of that, I have 2 numbers in the middle. So out of those 2 numbers, I can consider one number to be x bar. So I'm considering this number to be x bar. So I write x bar, right? Okay, let me not. This is a bit easier. If I say this number is x bar, then it's a bit easier. So I write x bar. This is x bar. Now I do x minus x bar. So 242.5 minus 250.5, I get negative 8. 246.5 minus 250.5, negative 4. 250.5 minus 250.5, 0. 254.5 minus 250.5, this is positive 4. 258.5 minus 254.5, positive 8. 262.5 minus 250.5, that's positive 12. Which tells me that I have assumed 250.5 to be the assumed mean. That's why I have written x bar. So I did x minus x bar. Now I try x minus x bar squared. So negative 8 squared 64, negative 4 squared 16, 0 squared 0, 4 squared 16, 8 squared is 64, and 12 squared is 144. So sigma x minus x bar squared, I get 92. 64 plus 16 plus 0 plus 16 plus 64 plus 144 is 92. I'm sorry, that's not, I'm sorry. I will see whether I need it. I don't think I need that. All right, I don't need that. So I will not work it out. Let's try. Okay, now I have x minus x bar times f. So negative 8 times 4, negative 32. Negative 4 times 7, negative 28. 0 times 14, 0. 4 times 15, 60. 8 times 7, 56. 12 times 3, 36. This is what I need. That's 92. So sigma x minus x bar times f is 92. All right, let's try next one. Now what I need is x minus x bar squared times f. So it's x minus x bar squared times this times f, this 64 times 4, 256. Then 16 times 7, 112. 0 times 14, 0. 16 times 15, 240. 64 times 7, 448. Then 144 times 3 is 432. Now the question is, how do I know what values do I need? So the answer is, you write down answer what formula first. This is sigma x minus x bar square times f 1488, the sum of all these values. So I write x bar equals sigma x minus x bar over sigma f. So I need x minus x bar, right? And then I find the total of these. Sigma x minus x bar times f, because we have frequency. So I have this is the table I'm looking for, and the sum of it is 92. That's why first table I wrote is x minus x bar, then x minus x bar squared, then x minus x bar times f. You don't have to do it. This is the method that book shows. You can do it without it. I'll just teach you that method again after this. Let me finish with this. So this is 92 over the sum of values 50. There are 50 values, 1.84. all right. So original mean, this is the mean that we worked out using assumed mean, but that's not the original mean. So the original mean is x bar is, we have subtracted 250.5 from each value. So now you add it back. So 250.5 plus 1.84, 252.34. So approximately 252 grams to 3 significant figures. Now standard deviation, sigma square root of sigma x minus x bar squared f over sigma f minus x bar squared, which is 1488 over 50 minus 1.84. We have to use the mean that we got assumed, that one, right? It's not the original, because we are dealing with the values that we received after subtracting 150.5. So this is 5.13560, approximately 5.14 to 3 significant figures. Now you can do without finishing this table, but the problem is when you do that, you make mistakes. People tend to make mistakes. So whenever you try to work this by using assumed mean, so what you do is you write down the formula first. Write down the formula for the mean, write down the formula for the standard deviation, and check what I need. I need sigma x minus x bar times f. Then I need sigma x minus x bar squared times f. So you plot those x minus x bar squared, x minus x bar, then x minus x bar times f, then x minus x bar times squared times f. Plot those tables and then work it out. That will becomes easier. Let's not learn other part because it's very easy to make mistake in that. Let's follow this method. Number 2, a production line produces steel bolts which have nominal length of 95 mm. A sample of 50 bolts is taken and measured to the nearest 0.1 mm. Their deviation from 95 mm are recorded in lengths of millimeters and summarized as sigma x is negative 85 and sigma x squared is 734. For example, a bolt of length 94.2 mm would be recorded as negative 8. Right? All right. Next one. Find the mean and standard deviation of the x values. Let's try this first. All right. Mean. So, how many values are they? Nominal or sample of 50 bolts. So, n is 50. Now, Number 1, x bar, mean and standard deviation. X bar is sigma x over n. So negative 85 over 50, negative 1.7. Now standard deviation, square root of sigma x squared over n minus x bar squared. Let's try that. So it's square root of 734 over n 50 minus negative 1.7. Negative 1.7 square. Remember to keep the negative values always in the bracket, otherwise you'll get negative negative positive, but here it will be negative because 1.7 squared, negative 1.7 squared will be positive. All right, let's try that. So the answer is 3.43365, approximately 3.4323 significant figures. So now it says, what does it say? The 94.2 mm would be recorded as negative 8. So 94.2 will be recorded as negative 8. All right, let's try this. Now, since here we have to change, it says, okay, all right, so now standard deviation 3.43, right? So now we have to figure out x values. All right, standard deviation is 3.43, so the true mean is, let's see, 94.2 was recorded as 8, right? So I can say, because negative 8 is to the nearest 0.1 mm, so negative 8 becomes 12 times 0.1, negative 0.8. So 94.2 is recorded as that. So the original is minus, okay, 90, it's all right. So original will be 94.2 plus 0.8 is 95.0. That's what it becomes, right? Because 94.2 became 0.8, which is 8. So the original should be something what minus, how does it become negative 8? 95.0. That's what I do, right? I send it to the other side. 94.2 plus 0.8. Let's say this is x, right? If you don't understand that, right? So this is x. So x is 95.0, right? So the true mean is 95.0 minus, what is that? Negative 1.7. But again, remember, this is what? Assumed mean. So we have to work out to the nearest 0.1. So negative 1.7 times 0.1, which is 95.0 minus 0.17, 94.83. So the true mean, x bar true, is 94.83. All right, next, if you don't understand this, let me know. I'll try to make it a bit simpler than this, but I guess that's clear. But if you still don't understand, let me know. I'll just send just small clip on this only. Let's try the next one. Number 2, find the mean and standard deviation of the length of the bolts in millimeters. Okay, standard deviation. So what's the standard deviation there? We have calculated 3.43. Remember, if it is assumed mean, we are using assumed mean, then mean changes but not the standard deviation. Standard deviation remains the same. So standard deviation, when we assumed it was 3.43, so the true standard deviation also remains 3.43. Standard deviation doesn't change. Let's try the next one. Number 2. Now it says, find the mean and standard deviation of the lengths of bolt in millimeters. Give your mean to 4 significant figures. Let's try this. Alright, that's what number 2 is. Alright. This is number 2, sorry. Now number 3. One of the figures recorded as negative 18 suggests why this can be regarded as an outlier, right? Now, outlier, let's see. Generally we do 2 SF, 2 standard deviations away from the mean. Let's try for 3 standard deviation. All right. So 3 standard deviation from mean. Just a minute, please. When checking outliers, generally we do 2 standard deviation, but let's try here 3 standard deviation also. So mu minus 3 sigma less than equals the value, let's say x less than mu plus 3 sigma. Let's try this. So mu is the mean. So standard deviation is 0.343. Okay. Now here, when we are calculating from the original values, so when we are working with assumed mean, so we just need to check x value less than 3 sigma. I'm so sorry. So this is 3 times 3.43, which is 10.29. So any value between negative 10.29 less than 3 standard deviation less than 10.29, any value beyond this is an outlier, right? So I am trying negative 18, which is beyond this, so it's an outlier. Right? Let's try the next one. Even if we try 4 standard deviation also, 4 times 3.43, which is 13.72. So it is between negative 13.72 less than equals 4 standard deviation less than 13.72. Negative 18 is still outside that, so it's an definitely outlier. Number 4. Definitely an outlier. Let's try number 4. The figure of negative 18 is thought to be a mistake in recording. Calculate new mean to 4 significant figures and standard deviation of the lengths in millimeters with the negative 18 value removed. Now sum of x new. Original was negative 18. So negative 18 was included in this. So to remove, because we had added a negative 18, to remove we have to add positive 18. Negative of negative 18, right? We have to remove negative 18. So minus 18. So it's negative 85 plus 18, so it's negative 67. Now n new, there were 50 values, one value negative 18 removed, now we have 49 values. Sigma x squared was 734. We need to remove that also, minus negative 18 squared, so this is 410. So x bar new, sigma x new divided by n new, 49. So this is negative 67 over 49, negative 1, 18 over 49, right? So x bar new is, we had, it is 94.2, correct? And it was for, it's 94.2. Where is 94.2 coming from? Right, 94.2 plus 0.8 minus, why 0.8? Remember, it was considered to be 8, and 8 was to the nearest 0.1, so 8 times 0.1, that's why 0.8, and then minus 67 over 49 times 10. This was 67, right? Where are you getting it from? What is 49? The number of values. What is 10? You can write divide by 10, or because it was to the nearest 0.1, it's the same thing. It's the same thing. So I write it as 94.863265, approximately 94.864 SF. Now, few questions from here. When we return to school, we'll try again to explain. We'll just understand it one by one. The questions that you have problem, you might have problem in understanding this question. So I'll teach you in groups, in pairs. I think it will help. Let's try the next one. Number 3 now. All right. A system is used to at a college to predict students' A-level grade in particular subject using their GCSE result. The GCSE score in G and the predicted A-level score A, and for math in 2018, the equation of line of best fit relating them was A equals 2.6 G minus 9.42. This year, there are 66 second-year students and their GCSE scores are summarized as sigma G equals 408.6. Sigma G squared is 2545.06. Find the mean and standard deviation of the GCSE score. So N is 66. All right. Now mean. Sigma G over N. 408.6 over 66. 6.19090. Approximately 6.1923 significant figures. Standard deviation. Sigma G squared over N minus sigma G over N squared. Instead of x bar squared, I am writing that because I didn't write this exact form. That's why, or you can write the at least 5 numbers, 5 significant figures. So this is square root of 25.4506 over 66 minus 408.6 over 66 squared, which is 0.48390, approximately 0.48423 significant figures. Number 2 now. Find the mean of the predicted A-level scores using the 2018 line of best fit. All right. So A bar, what was it? Let's see. It was, equation was A equals, all right, let's try that. A equals 2.6 G minus 9.42. So A bar now 2.6 sigma g over n minus 9.42. 2.6, because I have changed A into A bar. A bar is the mean, so G should be changed into G bar, mean of that. Sigma G 408.6 over 66 minus 9.42. So that's 1052.94. So A bar is let me check the calculator. This is 2.6 408.6 divided by 66 minus 9.42, and I get 6.67636, approximately 6.6823, significant figure. Number 4, find the mean and median of the numbers are given 2, 8, 6, 5, 4 and so on. Hence write down without further working the mode, mean, median of the numbers next given. Alright, let me write the numbers 2, 8, 6, 5, 4, 5, 6, 3, 6, 4, 9, 1, 5, 6, 5. All right. So mode. There are 1, 2, 3 and 4 5s and 1, 2, 3 and 4 6s. So it's a bimodal. Bimodal modes are 5 and 6, 2 modes. All right, mean 1 plus 2 plus 3 plus 2 4s, 4 5s, 4 6, 8 plus 9, divide by 15. So mean is 5. Median, the middle number. So I need to arrange it and keep crossing it out. So it's 1, 2, 3, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6, 8, 9, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2. So median is 5. All right, now the numbers are all right. The next numbers are 20, 80, 60, 50, 40, 50, 60, 30, 60, 40, 90, 10, 50, 60, 50. So mean is, the original mean was 5, so now it is 50. Each number, if you notice, just a 0 is been added. So I will add a 0 to mean. Mode 5 and 6, so 50 and 60, and median 50. All right, next one, that was number 2. Number 3 now. It's 12, 18, 16, 15, 14, 15, 16, 13, 16, 14, 19, 11, 15, 16, 15. So 1 is added before the number. So mean, which was 5, is now 15. Mode, which was 5 and 6, is what? 15 and 16. Median was 5, so it's 15. I'm just adding 1 before the numbers. Again, number 4 now. The numbers are now 4, 16, 12, 10, 8, 10, 12, 6, 12, 8, 18, 2, 10, 12, 5. So I have multiplied by 2. 2 times 2 becomes 4, 8 times 2 becomes 16, and so on. So I'm multiplying by 2. So mean, original mean was 5 times 2, 10. Mode was 5 times 2, 10. Median, mode is 5 and 6. So it's 6, 10 and 12. Median is 5 times 2, 10. Number 5. A manufacturer produces electrical cable which is sold on reels. The reels are supposed to hold 100 meters of cable. In the quality control department of the length of cable on randomly chosen reels is measured. These measurements are recorded as deviations in centimeters from 100 meters. So for example, a length of 99.84 is recorded as negative 16. For example, for a sample of 20 reels, the recorded values x are summarized by sigma x is negative 86, sigma x squared is 4281. Calculate the mean and standard deviation of the values of x. Let's try this. Mean x bar is sigma x over n, negative 86 over n, it says n is 20, right? All right, so divide by 20, which is negative 4.3 meters. All right, let's try the next one. Now it says standard deviation, sigma x squared over n minus x bar squared. So this is sigma x squared 4281 over n, which is 20 minus negative 4.3 squared. So which is 13.984, approximately 14.0. 3 significant figures. Number 2. Later it is noticed that one of the value is negative 47 and it is thought that so large a value is likely to be an error. Give a reason to support this view. Okay, let's check. Generally we check for outlier 2 standard deviations from mean. So x bar minus 2 times standard deviation less than equals mean less than x bar plus 2 standard deviations. So this is negative 4.3 minus 2 times 14.0 less than equals mean less than negative 4.3 plus 2 times 14.0. So this is negative 32.7 less than equals mean less than 23.7, which means any value lower than negative 32.7 or higher than 23.7 is an outlier. Negative 47 is much below than negative 32.3, so it's an outlier. Negative 47 is much more, or I should say much less than 2 standard deviation from mean. Number 3 now. Later it is noticed. Okay, number 3. Find the new mean and standard deviation of the values of x when the value negative 47 is discarded. Negative 47 is discarded. So sigma x new, negative 86 minus negative 47. So this is negative 39. Now n, which was 20. So 20 minus 1. Now new n is 19. x bar is sigma x over n, negative 39 over 19. So that's negative 2.0526, negative 2.05 3SF. Standard deviation nu, sigma x squared nu over n nu minus x bar nu squared. So how do I calculate sigma x squared? Sigma x squared nu is sigma x squared old minus, so what was sigma x squared old? Let's see. That was 4281. 4281 minus, right, 47 squared. So it's 2072. N is 19. Standard deviation nu 2072 over 19 minus negative 39 over 19 squared. Because it's not exact, so I have taken sigma x over n. Instead of writing this, I have taken this value. It's always safer to do that. We get exact answer, 10.239, approximately 10.223 significant figures. Let's try the next one. Let's try homework question 6. All right, question 6. What about question 7? Yeah, you can try question 7 also. Let me try 8. For a set of 20 data sets, so n is 20, sigma x plus 3 is 140, sigma x plus 3 squared is 1796. Find their mean and standard deviation. So mean, sigma x plus 3 over n. Because 3 was added, I have to subtract 3. 140 over n, 20 minus 3. Answer is 4. Standard deviation, sigma x squared over n minus sigma x over n squared. Sigma x squared, which is x plus 3 squared, I should have written, because standard deviation doesn't change as we discussed. Sigma x plus 3 squared over n minus sigma x over n. Okay. Plus 30, x plus 3, not 30. So this is 1796. Sorry. Over 20 minus 140 over 20 squared. We do not use this, we use that, right? Because this is, when we are using assumed, we use assumed. All right. So this is 6.387 dash dash dash, approximately 6.39. Remember, we are using assumed values by adding 3 each time. So x bar should be the same, not the final answer. So standard deviation is 6.3923 significant figures. Let's try the next one. Number 9 now. For a set of value of 15 data sets. Number 9. Sigma x plus a is 156. Sigma x plus a squared is 1854. N is 15. The mean x bar is 5.4. Find the value of a and the standard deviation. Let's try. Mean x bar is sigma x plus a over n minus a. X bar is 5.4. Sigma x plus a, which is 156 over 15 minus a. So 5.4, let's send 5.4 to the other side. So a, I'm sending a to the other side and 5.4 to the other side. So 156 over 15 minus 5.4. So a is 5. Done. Now standard deviation. sigma x plus a squared over n minus sigma x plus a over n. So this is 1854 over n. N is 15 minus x plus a squared, 156 over 15 squared, and I get 3.929, approximately 3.93 to 3 significant figures. Let's try number 10 now. For a set of 10 data items, so n is 10, sigma x minus a is negative 11, sigma x minus a squared is 75. The mean of the values is x bar is 5.4. Sorry, 5.9. Mean of these values is 5.9. Find the value of a and the standard deviation. Let's try this. X bar sigma x minus a over n plus a. So 5.9 is negative 11 over 10 plus a. So a is 5.9 plus 11 over 10. My bad. So a is 7. Now standard deviation is square root of sigma x minus a squared over n minus sigma x minus a over n squared. Remember the formula. Though these formulas are given, let me just send you. You can print it out and keep it with you. 75 over 10 minus negative 11 over 10 squared. Just check if this formula is given. 2.5078798. So standard deviation is approximately 2.51 to 3 significant figures. 11. The length of time, T minutes, taken to do the crossword in a certain newspaper was observed on 12 occasions. The results are summarized below. Sigma x, T minus 35 is negative 15. Sigma t minus 35 squared is 82.23. N is 12. Mean x bar. Here I would write t bar because its t values are given. T bar is sigma t minus 35 over n plus 35, which is negative 15 over 12 plus 35. So t bar equals 33.75 minutes. Next one, standard deviation, square root of sigma t minus 35 squared over n minus sigma t minus 35 over n squared. So this is square root of 82.23 over 12 minus negative 15 over 12 squared, which is 2.3. So standard deviation is approximately 2.3 minutes. All right, number 12 now. Easy questions. A summary of 24 observations. So n is 24. Give the following information. Sigma x minus a is negative 73.2. Sigma x minus a squared is 2115. Find the mean of these values of x is 8.95. X bar is sigma x minus a over n, negative 73.2 over 24. Okay, I made a mistake there. I forgot to add a there. So it's negative 73.2 over, what's that? 24, right? Plus a, and x bar given was 8.95. This is 8.95. So I'm setting this to the other side. So a is 8.95 minus minus is plus 73.2 over 24. AE is 12. Number standard deviation now. That was number 1. Number 2. Find the standard deviation of these values. Standard deviation is square root of sigma x minus a squared over n minus sigma x minus a over n squared. So that's 2115 over n is 24 minus negative 73.2 over 24 squared, and that's 8.878, approximately 8.88 to 3 significant figures. Hope you understood everything. If you have any doubts, kindly feel free to contact me.